Illustrates a normal distribution for the prices paid for a particular model of a new car. The mean is 12,000 and the standard deviation is 500. Use the 68, 95, 99.7 rule to find the percentage of buyers who paid between $10,500 and $12,000. Okay. In this particular example, we are given the data. It's already written out for us. Remember that you would always go ahead and put the mean goes right here in the middle. And then you go, add one standard deviation, subtract one standard deviation. That's why we get you add 500 and you subtract 500 to get the next two. And then you go up two standard deviations. So you add 500 again, subtract 500 again. Go out three standard deviations, again, above and below. So that's going to give you 99.7% of the data items. What we're looking for in this particular example are just the ones that are between 10,500 and 12,000. So I want it to be between here and here. So really I'm looking at these three standard deviations below the mean. It'd be a lot easier if I were looking for everything below the mean, because then I know that half or 50% is below the mean. And in this case, that means 50% is going to be below $12,000. So the problem with going with that number is I've got this little tiny piece out here that I do not want to include. So if you don't want to include it, you're going to have to subtract it. So what I need to do is take half and then subtract that little piece right there. So how do I find the percentage of that little piece right there? Okay. So if you recall, three standard deviations plus and minus is going to give me 99.7%. So the little pieces outside of here, both of these here, are what's not included. So I have 100% minus the 99.7%, which will leave me with 0.3%. Half of that is here and half of that is there. So I'm going to take half of my 0.3%. So 0.15% is what lies in right here. And like I said, we have half is going to be below 12,000, so I take my 50% minus this little piece here, so minus the 0.15%, and that gives me 49.85%. And so that's the part that will make up this little piece, and this one right here. It's not the only way to do this particular problem. You could have approached it another way of finding the area of just this one, and just this one. I just find it more direct to take half and subtract the one little piece as opposed to finding all three of those separately.